Hello, everybody. Um, I'm recording this the Friday before EmberConf. Unfortunately, of course, I couldn't come to Portland as I did in the past like 5 years or so. First time I'm speaking, and first time I'm not actually there at the same time, which is unfortunate. But I guess this is kind of a special situation, obviously. So. I don't have proper recording equipment here, but I hope this is gonna be good. And let's get started. So, welcome to my bonus conf talk, Decorators in Depth. I'm Marco. I'm from Germany, specifically Bavaria, where people sometimes look like this. I am the founder of Simplabs. We're a web engineering consultancy. We build digital products for companies around the world. And we also help teams to be like more effective with Ember, deliver better quality in shorter time, maybe, and just sort of to get the most out of Ember. Um, and you might know us from our open source work. We maintain a bunch of like well-known add-ons in the Ember ecosystem. We also sponsor the Ember project as such, with people writing for the Ember Times, for example. We did a lot of work on the website. We have people on the learning team, and so on. And we co-organize EmberFest, which is Europe's Ember conference, obviously. And my notes say here I brought stickers. I didn't actually bring them, obviously. I think I sent 800 to Portland, which I don't know, are maybe now in the Tilt office, and like maybe we can distribute them some other way. But here's how the sticker um, looks for this year, and the dates for this year are going to be October 15, 16. We don't actually say what the host city of the conference is. As every year, sort of, we have this sticker with a background that sort of gives some visual hints on the location, and then we let people guess. It's like our poor man's marketing strategy. I think it worked pretty well in the last years. And yeah, see whether somebody let's see whether somebody can guess this year's host city. We will, of course, reveal it soon, but I guess at the moment it's not even clear whether everybody will be able to travel anywhere in Europe in mid-October. Hopefully, yes, but we will hold off a bit until the situation smooths a bit more. Um, so I have some opening story for the talk, which doesn't really work anymore. I'm still going to do it though, because I couldn't really come up with anything better. So this is actually, like I said in the beginning, it's the first time I speak at EmberConf, right? And the joke that I want to make is that it's the first time that I'm speaking, and I almost didn't make it to Portland. Now, of course, I actually didn't make it to Portland, but let's still sort of go through the story, because besides Corona, there's actually another reason why I would almost not have made it to Portland if Corona hadn't happened. At all. And that has to do with this thing, the electronic system for travel authorization, called ESTA, which is what all of the non-Americans or Europeans, or so I don't really know like, to who it applies, but everybody from Europe has to sort of go through this system, sort of to register with their like passport number and so on before they can go to the US, right? And then that gets approved, and then you can go into the country without a visa. And in order to go through this, you have to answer all kinds of questions. Like one question is, have you ever violated any law related to possessing, using, or distributing illegal drugs? Which I don't know. This might be the one where like many people would actually lie, I guess. There's also other questions, like do you seek to engage in or have you ever engaged in terrorist activities, espionage, sabotage, or genocide, which I guess or hope most people can actually honestly answer negatively, right? But there's also a new question since I think summer last year, and that is, have you traveled to or been present in Iran, Iraq, Libya, North Korea, Somalia, Sudan, and so on after 2011, after March 2011? And the problem is, here's a picture of me in North Korea in 2012. Here's me. Here's a statue of, I think, Kim Il Sung, and here's a bunch of flowers that I just had dropped in front of that statue. And I should say that is not actually sort of me expressing my support for the regime. It's just something that you're sort of expected to do when you're there. So I answered that new question honestly, and not surprisingly, my travel to the US was not authorized. So now I need to get a visa, which is actually a good thing because now I have a 10-year visa and I don't have to go through ESTA anymore. And somebody told me I would have been able to sort of at immigration take like a faster lane or so. I might find that out next year. And getting the visa was really easy. The person at the embassy found it pretty convincing that I went to North Korea for vacation. But yeah, having the visa doesn't help me now, of course, right? And of course, it's not really up to me sort of to judge US policy, but I'm not sure it's fair that I need a visa now because because I have been to North Korea once. Because um, here's me and my guide in North Korea. That's Mr. Kim. Obviously, in North Korea, you cannot do anything without a guide, right? And the guide is not actually a guide; it's more like a person that's watching you, right? And they are being watched themselves, right? But the thing is, I don't seem to be the only one maintaining relatively close relationships with North Koreans, right? So it seems a bit like there's different rules for different people here. Although I will admit that I did not fall in love with Mr. Kim over beautiful letters, but just over beers, as people do. Um, yeah, it's like maybe a bit of double standards here. So anyway, I thought this might be a good opening story for the talk. Now, as I said, sort of it doesn't work anymore really because now I'm sitting here in Munich, but so like having added that story to the talk, I thought like maybe there's a way sort of connecting the talk's main topic, which is obviously not North Korea, but JavaScript decorators, like connecting the two topics a bit, right? And having sort of a JavaScript decorator / North Korea talk. And then I was thinking about how I could do that. And the first thought I had is just this statement, which sounds pretty nice, right? Decorators are the North Korea of JavaScript. But what does that even mean, right? It's basically just a bullshit statement that sounds very good, but it means nothing. So unfortunately, there will be no more North Korea content in this talk, just because I couldn't find a proper way to get it in. But back to the topic, and I want to start with some theory. So the theory behind something like JavaScript decorators um, is attribute-oriented programming. And the idea behind attribute-oriented programming is that it is a program-level marking technique that allows you to mark elements in your program to indicate that they maintain specific, like application-specific or domain-specific semantics without leaking all of the details of those semantics into your core logic, so to say, which then increases abstraction and reduces complexity, right? And many languages have had similar concepts for quite some time. For example, in Java, you have attributes like deprecated, which allows you to mark a specific thing in your code, like a class here, as deprecated. Of course, you could also do more sophisticated stuff. So here's an example from Hibernate, which is a very popular object relational mapper in Java. And here you see we use the entity attribute and the table attribute, ID attribute, and so on, to sort of define how the mapping from instances of the employee class to a particular database table should work, or other way around as well, of course. But the thing here is we're not leaking any of the details, like any of the sort of internal mechanisms of this mapping into the application code, right? We keep it relatively clean because we just sort of attribute the elements with the respective attributes without sort of revealing how those work internally. This concept doesn't only exist in Java, though. There's also a similar concept in .NET. So here, for example, we're using JSON property attributes to define how instances of a particular class, and in this case, the API error class, are serialized to JSON. And again, without leaking any of the details of the serialization process sort of into our application code. When we compare this to what we have in Octane, then it's obviously similar, right? So here we use the Tracked Decorator to mark the count property as tracked. So the template re-renders when it changes. And we use the action decorator to make the increment and decrement methods work as actions. So again, without leaking any of the details of these decorators or the concepts behind them into our application code, right? We just say the count property should be tracked. We don't care about how that works internally or what tracking even means, sort of. That's not a concern of our application, but that's a framework concern. So there's no point sort of leaking any of the details of the concept of tracking, or the concept of making a method available as an action or work as an action into our application code. So we want to hide all of that, and we do hide all of it behind that decorator. So this is how JavaScript decorators fit into sort of the general concept of attribute-oriented programming. So you add attributes to the code to express additional semantics while hiding all of the details. But later we will see there's actually a fundamental difference between JavaScript decorators and attributes in other languages. We will look into that in more detail later. Sort of on the surface, it's sort of the same thing, and it's meant to serve the same purpose. The insights sort of are a bit different, but for now we can ignore that. So then you might ask, are decorators ready for use? And the answer is it's complicated, unfortunately. And again, I want to share some background here. So as most of you know, or everybody presumably, TC39 is the group that defines the ECMAScript standard, and that's JavaScript. It's an international group of people with various backgrounds, that represent different interest groups like larger companies, browser makers, and so on, but also sort of the viewpoint of the average JavaScript developer, sort of, which I think was one of the main motivations for Yehuda Katz. Like, obviously, as you know, one of the sort of inventors of Ember, to join TC39, because I think that his motivation sort of was to make sure that the average JavaScript developer's viewpoint sort of was recognized in TC39 as well, and not only the interests of larger companies or browser makers, because sometimes those could be pretty different, of course. So that group of international people discusses ideas for additions and changes to the spec, or I guess in reality it's really additions only, because you cannot change anything in JavaScript, and it's basically an additive spec, because changing anything would break existing code and websites. So each new thing that they discuss goes through 5 stages. In stage 0, the thing is basically just an idea for a new language feature. So anybody could have that idea, and then when you find a TC39 member to bring it to the group, then it would get discussed there, right? At that point, the idea would usually be pretty vague. There's no indication of whether it'll go forward at all, or maybe like it's being discussed for 5 minutes and then immediately rejected for some reason or whatever, right? The next stage then is stage 1, where you have a written proposal with proper description, examples, and so on, discussions of semantics. And there's a TC39 member that champions the idea, sort of, right, or the proposal. So stage 1 means that TC39 is willing to examine, discuss, and contribute to the proposal. But there are still major changes to be expected, right? At that point, it's still relatively vague, and there's no indication of whether it'll make it into the spec eventually, or if it makes it, whether that's going to be a very different form, maybe. But if it's not rejected, then the next stage will be stage 2. At that stage, the proposal must have a formal syntax definition, description should be complete, there need to be, I think, 2 experimental implementations. One will usually be Babel, unless the feature cannot be transpiled to current JavaScript. Sort of, I think that was the case with proxies, because there's no way sort of to make the underlying mechanism of proxies work with current JavaScript. Obviously, experimental implementations can, of course, be in browsers as well, behind feature flags or whatever. At stage 2, a proposal can still be rejected. So it's relatively far in the process, but there's still no guarantee it'll make it. The next stage then is stage 3, at which point the spec text needs to be complete. There need to be there need to be 2 fully compliant implementations. Again, one of them would usually be Babel. And at this point, the proposal can be expected to be added to the spec, and changes should only be made when critical issues occur. And that's why stage 3 is sort of the important stage, right? Because at stage 3, you can expect the thing to be added to the spec eventually in only slightly modified form. So stage 3 proposals are pretty okay to use in general, right? While everything before or below stage 3 is not really okay to be used, because there's no guarantee it will actually make it to the spec, and there's no guarantee that if it makes it to the spec, it will be in the form that like in its current form, sort of, right? Yeah, stage 3 is the one that you want to keep in mind, because that's sort of when you're building on relatively solid ground, sort of, if you're using something in stage 3. The next stage is then stage 4, which is basically just like a stage that something goes into while it's sort of waiting to be added, but it's already decided that it will be added, right? So of course, now the question is, where are we with JavaScript decorators? And first problem is there's not 1, but actually 2 proposals. Second problem is one is in stage 1 and the other is in stage 2, and obviously that means that none of them is final or complete, right? The stage 1 proposal is basically deprecated, sort of. That's not going to be continued. And the stage 2 proposal is in stage 2, which means it's not done, right? It might still change relatively significantly. So let's look at some more details of those 2 proposals. First of all, the stage 1 proposal, which basically defines decorators as simple functions, right? You would just write a function that receives the element that you're decorating, and then you can modify the element, which is very simple, right? But it has major implications with respect to performance, because you're actually modifying the class or the method or the property or whatever. So you're changing the shape of things, sort of, which is always very bad for browser engines to optimize, right? So there are major performance implications. There are also major tooling implications, because you cannot actually statically analyze those decorators, right? If a class is decorated with a stage 1 decorator, you cannot really know what that decorator does. So you might not know for sure which methods that class has, right? Or whether the methods are actually as you see them in the class body, or whether the decorator does modify them, and then like the actual methods on instances or on the prototype will actually be different from what you're seeing, right? So that's of course a major problem as well, in particular for tooling, right? So the stage 2 proposal solves the performance and tooling problems by basically defining decorators as first-class language elements and sort of limiting them much more, but it's not ready yet. There are major changes to be expected, so it's not even really clear how exactly that's going to look, right? So coming back to my previous slide here, in reality, decorators are not the North Korea of JavaScript, but sort of the anti-North Korea of JavaScript, because nothing is regulated and everybody can do what they want, basically, because there is no official regulation or specification, right? So the question is, what do we do? The old thing is deprecated and the new thing is not ready. But in Ember, we need something that that works well with native classes, because the old macro methods that we've been using for computer properties, for example, and so on, they don't really work well with native classes. You have a bunch of options using them with native classes, so it's not impossible to use them. I think there might be some edge cases where they actually behave differently, but it's not impossible to use them. It's just not nice at all. So for example, if you had a person class with a first name and last name, and by the way, all those examples are, I think, taken from the IFC that I think Melanie Sumner wrote. I'm not 100% sure, but the examples have her name, obviously, so let's just assume she wrote it. So if you have a person class here with a first name and last name, and you want to define the typical full name computer property, right? Like full name must be sort of the hello world of computer properties, I guess. Then with a native class, you could define the class first, and then on the prototype, define the computer property, right? Which is obviously not what you actually want to do in your application. The alternative is you sort of mix like new native classes and the old Ember object model, and you define the class as an extension of sort of an anonymous class here, that where you use the old way sort of extending from Ember object. This works, but it's obviously also not really nice, right? The best solution is obviously with decorators, right? Where you just define a proper native class with two fields and one getter, and you just decorate the getter with the computed decorator here, right? So the question is, how do we get that when the decorator's proposal is not ready, really? And the answer is we just stick with the stage 1 proposal for now. This is what the TC39 champion group recommends. Because although the specification is not ready, decorators are already widely used in the JavaScript community. And Ember is actually relatively late to the party here. So projects like Angular also have used decorators for years now. So there's a lot of pressure, and also there's commitment, I think, from TC39 to make the final decorator proposal so that it will allow to do the to make the final decorator proposal so that it will allow for doing the same things with decorators that you can also do with stage 1 decorators. So that means you will very likely not have to change your usages of decorators, right? The decorators will only have to change internally to solve the performance and tooling problems. But that also means that you do not want to write your own decorators yet, because while usages of decorators will not have to change, the internals of decorators will change a lot potentially. So when writing decorators, you're building on pretty unstable ground, right? If you only use the decorators that Ember provides, then obviously Ember sort of shields you from all of the internal changes that might or will probably have to be made at some point. The computed property, the computed decorator and the tracked decorator will continue to work the same way. They will just be implemented in a very different way internally. One thing though is that in app code, you would usually, but there's usually not such good use cases for decorators anyway, because as we saw in the beginning, the purpose of a decorator is sort of making something available while hiding all of the details of that, right? Which is usually not something that you want to do in an application, right? Because in an application, you don't want to sort of hide parts of the code from the engineer, because all of your application code as a whole sort of is being maintained by your project team and so on. So you you don't want to introduce black boxes, right? It is, however, of course, something that has a lot of value for frameworks like Ember, or maybe even for add-ons. And understanding what decorators do, how they work, what they can do, what they can't do, sort of gives you a better mental model of your application, of course, which is also the reason why I give this talk. So let's look at the stage 1 proposal in more detail. We will basically ignore the stage 2 proposal for now, because it's unclear how it's going to work eventually. So we will focus on the stage 1 proposal. And like I said, the stage 1 proposal defines decorators as simple functions that modify the element that they are decorating. And that is also coming back to a previous point, that is that main difference between JavaScript decorators and attributes in Java.NET. Because while attributes in Java and .NET only add metadata sort of to the elements that they're attributing, JavaScript decorators actually modify these elements, right? So with a JavaScript decorator, you could actually modify a class, for example, where while an attribute in .NET will only add metadata to that class, so that at runtime you could reflect over that metadata and sort of do certain things then. Right? So that might, of course, be different in the stage 2 proposal, but for now, that's really the main difference, that a JavaScript decorator will actually modify the thing that it is decorating. Doing that, though, is relatively simple. There's basically two cases. There's the case where you are decorating a class, and in that case, the decorator is a simple function that receives the class constructor as its argument. You could also, of course, decorate a class member, in which case the arguments for that are the prototype, the name of the member, and a property descriptor for the property you are decorating. And I want to show you some concrete examples to make that a bit clearer. I have created a little example app, so you can find all of the code on GitHub. Let's look at the first one. So here we have a simple Ember route, right? We just load some data from an API endpoint. We don't care about the details, of course. And now let's assume we want to benchmark that, right? We want to like have something in place that allows us to benchmark the execution time and maybe report it somewhere or whatever. But of course, we don't want to sort of have all of the benchmarking code as such in the route, right? We want to hide that because it's not relevant to the application, really, right? Let's say we want to like make a benchmarking add-on or whatever. So a good way to do that, of course, is to use a decorator, as we're doing here, and we're just importing that as any other thing sort of in JavaScript, and then we're decorating the model method. And as I said before, the decorator using the stage 1 proposal, the decorator is just a simple function that takes the prototype, the property name, and the property descriptor for the property we're decorating as arguments. And what we're doing here is we're simply remembering the original value of the property descriptor, which is the original implementation of that method, and then we replace it with a wrapper. Right? And here what we're doing is we stop the time when we start execution, then we call the original method. We stop the time when that ends, and we log that to the console. In reality, you might be logging to some sort of API or whatever. And then we return the result that we got from the original method, right? So we do not change the original method. We also don't change the signature of the method because the method that we are replacing the original one with has the same signature, right? We're just adding our stuff sort of before and after the original method. And that also means, of course, that the original model method doesn't even have to know that it is being benchmarked or that it is like wrapped with something else, right? Which is the point of a decorator, of course. Another example is this one here. So let's assume besides benchmarking the model method, we also want to require users to be logged in to have access to that route at all. And by the way, this is a sneak preview sort of what a version of Ember Simple Auth, which we at Simple Apps maintain, without mixins could look like, right? You can use mixins with native classes like relatively easily in Ember, but it's not really great, right? In the current version of Ember Simple Auth, you would just mix in the authenticated route mixin into this route that you're defining here. But with a decorator, it's even a bit nicer and sort of has a more modern look as well. So what we do here is we just import the authenticated decorator and apply it to the route class, right? And again, the decorator is a simple function that takes the class constructor as an argument, and we do a similar thing here to what we did before. We remember sort of the original implementation of the classes before model method. And then we replace it with our own method. And what we do in that method is we get a session or the session service. We check whether the user is logged in. If it's not the case, we just transition them somewhere else. In this case here to index would probably make more sense to transition them to the login route. And if they are logged in and there's an original implementation of before model, we just call that, right? So again, we are adding sort of relatively complex logic with a very simple mechanism, and we are hiding all of the details. We don't change the original before model method. So I think this is a very nice example for how decorators are actually a pretty good way of making functionality in add-ons available for Ember applications. Obviously, those examples are sort of made up. They don't really have any sort of real value. It's just for illustration purposes here. So I also want to look at two examples from Ember itself. And if we look at this this piece of code here from previously, again with a component that has a tracked property called count, and then two methods that we decorate with the action decorator, so we can actually call them as actions from the template. So how does this work? And first of all, let's look at the tracked decorator. And this is not really the code from the Glimmer code base. It's sort of the essence of the code, right? But here you see that we have a function here that takes the prototype, the property name, and the property descriptor as arguments, right? Because it's a stage one decorator applied to a class member. And what it does is a very similar thing to what we saw before. It replaces the original property with, in this case here, a getter and a setter. We can ignore the getter. That's not so interesting. But the thing, of course, about tracked properties is that whenever a tracked property is modified, then the template re-renders, right? And you see how that works here in the setter, where whenever the property is set, the property to change callback will be called, which is sort of an internal callback in Glimmer, which sort of triggers a re-render, right? So that is basically how the tracked decorator inside of Glimmer works. It just replaces your original property with sort of a wrapper property that will make sure that whenever the property is set, and internal callbacks are sort of in Glimmer is called, which will then trigger a re-render. Next, let's look at action. And as you all know, the main thing about actions is that they are closures that are already sort of pre-bound to the correct context, right? So you can just call them as a function, and they will be running with the correct this binding, sort of, right? So basically, besides a bunch of other things, like you see the dotted lines here, basically are like relatively big parts of the actual code that are left out here. But sort of one of the main things that the action decorator does is it binds the method you're decorating and assigns it to a hash of actions, right? And that allows you then to use like the method as an action from the template. So this is decorators in Ember. They are a great way for abstracting logic that is non-essential to your application, but that is maybe only essential for the framework or only essential for some other system sort of you're using. But there's no stable spec, which means you don't want to write your own unless you have lots of time and lots of willingness sort of to potentially rewrite lots of the internals of the decorators you're writing. And that's all that I have. Thanks. Unfortunately, I can't take questions. Unfortunately, I can also not talk to people sort of after the talk or in breaks or whatever. But we'll repeat all of that, I guess, next year in Portland or at Emberfest in Europe this year. Thank you. Bye bye.